Our next presentation is from Josh Lepawsky from the Department of Geography at Memorial University of Newfoundland. Josh's work on the social, economic, and environmental consequences of manufacturing and the practice of using and discarding digital technologies has been transformative. His research bridges disciplines and enhances the scholarly and societal understanding of global electronic waste management and its implications for Canadians in an increasingly digitized world.
Hello, my name is Josh Lepawsky. I'm a professor of geography at Memorial University. In what follows, I'm going to show you a little bit about what my research does. There's still a pernicious tendency to treat digital technologies as if they exist in a weightless and ethereal elsewhere. Think of the cloud that stores our data, or indeed that is facilitating this very discussion. As a geographer, I map the pollution, waste, and discards that accompany the lives of electronics. I'm interested in how electronics stand in for both dreams of technological futurity and nightmares of social and environmental breakdown. I'm also interested in how maintenance and repair, broadly conceived, might offer both literal and figurative lessons for figuring out how to live well together in permanently polluted and always breaking worlds. This image shows the Chuquicamata copper mine in northern Chile. The electronics industry is the second largest consumer of copper. Chuquicamata is roughly 3.5 kilometers wide and 850 meters deep. After about 12 hours of operation, it generates as much mine waste by weight as Chilean consumers discard old electronics in a year. After a little over 48 days of operation, this mine generates about the same amount of waste as the total annual weight of electronics cast off by consumers in China and the United States combined. Today, in Silicon Valley, there are operations currently running to clean up groundwater pollution from electronics manufactured there in the 1970s and 80s. That infrastructure will finish the job roughly 700 years from now, in the year 2720. Usually, when electronic waste or e-waste is discussed, the story defaults to a post-consumer view of the problem. E-waste is what happens when people, consumers, throw away their devices. This image shows the massive waste arising from the mining for and manufacturing of electronics relative to post-consumer discards. Of course, post-consumer discarding happens, but this is actually the smallest part of the overall waste arising from electronics. Much more waste, by far, happens in mining for and manufacturing of electronics, long before consumers even purchase their devices. It's important to understand this because how one thinks about a problem makes some solutions seem obvious, even natural, while other solutions become less obvious and less actionable. They may even become unimaginable. So part of what my work is about then are problems of knowledge. How do we think we know what we know? As science and technology studies scholar Brian Wynn argued decades ago, hazard and waste are fundamentally ambiguous. Their intrinsic physical meaning is not given and objectively predetermined in nature. For example, the same chemical compound, polychlorinated biphenyls or PCBs, are regulated differently in the US and the UK. The US permits 50 parts per million of PCBs to enter landfills. The UK permits 10 parts per million of PCBs. Yet there's no neutral or objective third party that we could go and check with to determine which of these numbers is right and which of these numbers is wrong, or which is hazardous and which is not. They are both and. So another aspect of my work is about how to act in situations characterized by this kind of indeterminacy as it relates to pollution, wastes, and other discards. This map represents publicly available pollution data at the facility level for the electronics sectors of Canada, the US, and Mexico. Each color is a different chemical. There are so many chemicals tracked in the data that there are not enough colors available to represent them all. The The size of the circles are proportional to the mass of pollution releases. The map shows us that the pollution arising from electronics manufacturing is ubiquitously but unevenly distributed well beyond Silicon Valley, even as production has been moved overseas. But there are real limits to what the map can tell us and, indeed, what can be mapped. Different jurisdictions count pollution differently. Each of these circles is sized proportionately to show the different number of chemicals tracked by industrial pollution release databases in the US, Mexico, Canada, and the EU. Out of the hundreds of chemicals tracked, only 10 chemicals are common to all. What these numbers mean is that the same industry or company will look different from a pollution release perspective depending on which jurisdiction one looks at. But that's not all. The magnitude of chemical releases actually tracked is tiny compared to the number of chemicals tested and found toxic. At the tip of the blue arrow are the pollutants tracked in the databases I just highlighted, sized proportionately to the number of chemicals tested and found toxic, what you see in the yellow circle. In the yellow circle is the number of chemicals tested and found toxic, but which we have no information from the pollution release databases because those databases don't track them. So there are fundamental limits on what we can even know in principle about the pollution releases from industry and companies in the electronics sector or other industrial sectors. As a consequence, a broad question that is now animating my work is how might variable collectives of people, places, and things learn to live well together in the chemical galaxy left in the wake of electronics? Thank you so much for watching and listening. If you would like to find out more about my research, head to the Electronic Planet Research Lab's webpage at electronicplanet.xyz, or you might like my recent book, Reassembling Rubbish, Worlding Electronic Waste. Thank you again.